It is now the top of the hour. So first, I'd like to welcome everyone. My name is Melissa, and I will be the webinar moderator for today's event. Welcome to the 5th Masterclass Series webinar of OMS eLearning Academy. Today's webinar topic is Crude Blending, Part 2, Analyzers and Controls. We have an overwhelming response of 80+ registrants from 30 countries, and welcome you all, and hope you all will have a very informational and interactive session. Before we start, let me please go over some house rules. The webinar will be 40 to 45 minutes long with 10 minutes for a Q&A session. You can enter your question in the chat box during the presentation, and it will be answered at the end of the presentation. Please note the chat box is located at the bottom right corner of the screen. You can click on chat. Please remember to select everyone. Once you select everyone, we will definitely be able to see your chat question, and we will be able to answer them during the 10-minute Q&A session. This webinar will be recorded and available on the OMS eLearning Academy website. There will be 2 questions at the end for your input, and they will be 2 poll questions. Please give us your candid feedback at the end via the redirected Google form. We have 2 speakers in today's webinar. First is Dr. Suresh Agarwal, the founder and CEO of Offsite Management Systems, LLC, and Academy Director of OMS eLearning Academy. The second speaker is Dr. Ariel Kaget, R&D and Business Development Manager at UK-based Modcon Systems, Ltd. I welcome them both to speak at this educational free webinar. Offsite Management Systems, LLC was founded in 1998, Houston, Texas. It is chartered to provide consulting and refineries automation projects executions around worldwide. OMS eLearning Academy was founded in 2018 to provide continuing education to professionals working in the downstream refining industry and related businesses via the e-learning platform. The Academy has 200+ courses that can be taken online, anytime, anywhere, and on any device. Modcon is a UK-based company founded in 1972, specializing in process analyzers, technology, and blending control systems. OMS and Modcon have collaborated to bring their technologies to benefit professionals in the process industries. You will learn 3 ideas of Crude Blending Part 2 Analyzers and Controls in this webinar. Review of content and economics, as provided in previous webinar Part 1. Crude Qualities Analyzers, Online Control of Crude Blending. And with this, let me request today's speaker, Dr. Agarwal, to start the webinar. I'll be back at the end of the presentation with the Q&A session.
Thank you, Melissa, and welcome and greetings, everybody. And I especially thank Dr. Ariel Kriegel to be co-presenter with me on this webinar. As Melissa said, Modcon and OMS has collaborated many topics and will continue doing so in the future. Now, I want to just give a little bit of background, which was also already presented in the part 1, just to have a continuity and for the benefit of people who could not attend the previous webinar. So I'll review the concept of economics very briefly of crude blending, talk about crude supply and blending cycle. I'll show an example of how do we optimize a crude recipe for 2 to 4 crudes. And then it will be from Dr. Ariel to talk about analyzers, technologies, and crude blend control optimization, and challenges for success of crude blending systems. There have been challenges for the refining industry. For last 30, 40 years, the crude qualities had been changing from the source, and there's tight regulations from the industry and the customers. I remember I worked my first crude blending quality in 1980s for a Spanish refinery. At that time, the concept of crude blending was just coming up. Refineries were seeing the issues in getting the quality of the crude for their refineries. What it led to, the refineries started realizing that they must be very flexible enough to respond immediately to oil changes and deviation in product demand due to changing global economy. Well, last 2 years have been tough because of pandemic. Crude supply and the refinery processing industry has suffered some setbacks. So it's very important that refineries management should be flexible in terms of how they operate the refinery for the maximum profit. The crude price differential, there are different sources of the crude, and the prices depends upon availability, demand, cost of transport, especially by their qualities, which is governed by API, sulfur content, and total acidic number. There have been a number of mathematical approaches and models to set the prices for a particular type of crude. I had talked about it a little bit in the previous webinar, so I will not touch in detail, but the price is a very complex scenario for the crude prices. And the oil prices are very volatile, depends upon the economic growth, supply and demand variables, and market disruption, as we had last 2 years due to pandemic. The refinery industry trends, the refinery gross profit, makes less than 5% of the revenues. So they have a very challenging situation where they have to increase their margin, and to do that, they have to reduce the feedstock cost and decrease operating expenses and increase product revenue. Now, some of these concepts I had talked about in previous webinars and recording available. You can always review them again to see what the refineries are suffering from factors which is out of their control. So if we take a journey of crude from supply of crude to the supply of products to the consumers, we have 3 stages. First is the crude blending, and then crude unit control, and the product blending. And each of them have to be very efficient and effective for refinery margin to improve, or at least keep constant in the current level on the past this thing. So we'll talk about all this thing briefly, but the topic of this webinar is mostly the crude blending, and product blending is in the next webinar. So from crude well to customer cycle, so the traders supply the crude to the refinery based on the spec, and then once the refinery produces products, it's shipped back to the consumer. So this is a cycle, goes from oil well to the shipment to the refinery and products back to the consumer. And each of these have a very complex operation and requires a very effective control systems and management. So if this is how crude blending and product blending are synced together. So on the left-hand side, we get a crude supply from different sources like tankers, pipeline, trucks, or rail wagons, and it's come to the refinery and is stored in the crude oil tanks. And then from there, it goes to the blender to feed to the crude units. And it has the control units, control qualities of API, sulfur, TAN, salt, and distillation. And once it goes to the process unit or crude unit, it creates a blend stocks, and then it goes to the blending of the products, all the gasoline, diesel, and other products. Now, so there are 2 major factors or 2 major systems in the refinery operation: the crude blending and the product blending. And what happens in between is the movement of material from tank to tank on different sources. These 2 operations of crude blending and product blending are the most profit generator for the refinery, and any deficiency in this operation can have a setback for the profit margin. So typically a refinery deals with 5 to 10 crudes. I haven't seen in my career where refinery have an unlimited source of supply. So I did a little bit of mathematics. Says okay, if a refinery deals with 5 to 10 types of different crudes, and they are blending 2 crudes at the same time, or 3 crudes or 4 crudes, you can see the number of possible combination, how they can create a crude blending using 2 or 3 or 4 crudes. Now, that doesn't mean all these combinations are possible. And you will see later on in this webinar, uh, uh, some of them may be infeasible solution. And the feasibility requires that the crudes should have a higher and lower qualities than the blend spec. And then only it can be feasible. So out of, say, for example, if you have 5 types of crude and you have 2 types of 2 crude blender, you have a combination of 10. Out of 10, you might have a 4 or 5 or 3, depends upon what crude quality you have, and so on and so forth. And this can be determined very easily using the optimizer. So the challenges of crude blending, which is unlike the product blending, is that there are only 2 qualities, API and sulfur, and these both qualities are nonlinear because API depends the density, and density depends, is affecting the sulfur. So they are not, it's a nonlinear due to API and density relation. So it becomes it may seem simple, but it becomes difficult mathematically how to optimize the recipe. So we have worked on this solution, and we determined that for the 2 crudes, if you have binary crudes, the solution is unique. There is only one recipe for binary crude. And that can be used by iteration, simple mathematical iteration, few seconds. When it goes to 3 and 4, it becomes more complex. You have to run iterative solution many times, and you have to use random search methods. And I'll demonstrate to you later. So even though it seems simple compared to product blending, but mathematics is a little bit tricky to create a recipe for the crude blending. So each refinery has a database of crudes that they deal with. I just took a sample of 30 crudes for the optimizer, and it shows anywhere between low density, low API to high API and different layers of sulfur. And based on this database, you can select any crude for the optimizer, whether it's a 2 crude blending or 3 or 4 crudes, and you can see which will give you the maximum profit or cost, or it meets the spec. And I'll give you a demonstration. This is the optimizer. It's an offline optimizer similar to what we do for fuel blending. And this one shows that we have blending 4 crudes. 2 are light and 2 are medium, both are sweet and sour. And when we run this optimizer, it estimates the initial recipe and keeps on iterating until the root mean square error becomes the least, because that's the only criteria we have. We don't have the profit as we have in, or giveaway as we have in fuel blending. So our criteria to optimize this only minimize the error from the crude spec. And you can see here that after many iterations, we give a global optimum or a global situation for the recipe. It goes through many iterations, and at the end, we get one global. And we have run this for many iterations, and ultimately, no matter how many iterations you run, 100 or 200 iteration, which takes about 4 minutes, you ultimately reach the same global optimum. Now, this is an example of, I've taken 2 crudes, 3 crudes, and 4 crude blending, and run about 100 iterations. And for binary crude, the optimization was reached within less than 30 seconds. For 3 and 4 crudes, took 4 or 5 minutes and give me the global optimum and give the recipe at the bottom. Now you can see in the bottom screen, it shows the blend API, higher spec, and profit. Now, refinery have to make a balance between the cost of processing higher sulfur or having a profit. depends whether it's a trader or it's a refinery in-house blending. So it's a balancing of the two, whether you process the higher sulfur or you reduce the cost of your crude supply. Now, so I ran 3 or 4 different types of blend for binary, 3 or different types of crude for 3 crude blends and 4 crude blends. And you can see the difference between the cost and the error from the spec. And sometimes that becomes a criteria for a refinery trader or a planner to what is they want to do. Do they want to go to lower sulfur and lower profit, or they can use a higher sulfur and balance against the profit or cost they will save? So it's a trade-off, and that varies from refinery to refinery, what criteria. But this gives them a tool that they can analyze different combination of the crudes with a 2 or 3 or 4 and see what is their ultimate recipe will look like. So there are 2 sources of crude blending. Either refineries can buy directly from the trader. A trader can supply either individual crudes or they can supply the blended crudes. If they supply a blended crude, then they have to try to minimize the spec or what refinery can accept it. So whatever they sell is their profit. But they are only considering compatible crudes. Crude supply is mostly by pipeline, sometimes by tankers. It does not require much refinery on-site storage for single crude type before blending. The consequence of the cons of this is that the savings from blending is for the trader, not so much for the refinery. It has a high transportation cost. Mixing may be an issue, and blending is done mostly in pipelines. On the other hand, a refinery installs a crude blender, either standalone, small footprint, or pipeline blending, as I've seen some of the refinery work with. It has a flexibility, whether they can blend 2 crudes or 3 crudes, and they can do a first stage, a second stage blending. It keeps the savings, and they can do multi-crude blending. I have worked with a refinery which has 5 crude blenders and 5 units. So it was a complex one. They can also do a simpler binary crude blending on site. Consequences or disadvantage that requires on-site crude storage tanks. Mixing requires attention and composition tracking because each tank could have multiple crudes, so they need to know what crude composition are each tank. Now, this point, I'll hand over to Ariel, who will talk about controls analyzer. I'll give him the control.
Dr. Surish, thank you very much for the introduction. Just a second, let me return to the previous slide. Can you please return to the previous slide? I still don't have control. I believe it takes a few seconds. Yes, okay, thank you. So before we start discussion on the blending station and the equipment to be used for the blending station, it's very important to understand what is a crude oil and what are the properties of interest that characterize this material. Crude oil is actually a mix of hydrocarbons that is used mainly for the fuel and chemical production. Crude oil identified by a long list of properties, while each one of them has importance in processing. Most of the properties measured online and allow having better process control. Let's look at the below list. First of all, API gravity and sulfur, important parameters related mainly to the commercial aspects of the crude oil, but these are not enough for the processing needs. Sulfur concentration, a parameter that will be specified during all the processing cycle, from the crude oil distillation to the final products blending, like gasoline or diesel. Therefore, it's important to track its values during all the process, from the beginning till the end. Vanadium and nickel, common trace metal in the petroleum, its presence in the fuel can cause problems due to few factors, formation of corrosive combustion products like vanadium pentoxide. It also might influence and inhibit the catalysis during the refining, or even impact negatively on the environment. These parameters, vanadium and nickel, as a standard measured in the laboratory, and no process control is required. SARA is for saturates, asphaltens, resins, and aromatics. Analysis that divides crude oil components according to their polarity. SARA analysis would help estimate compatibility and stability for the crude oil during the blending. It also provides information about the asphaltation stability and tendency for coking. Next parameter, light ends, for understanding better the light content of crude oil for further separation. Total acid number and salt content measured for the crude to better understand the crude corrosivity parameters in order to prevent them during the processing. Salt in crude oil can also be helpful in tracking the desalination unit efficiency. As a standard analyzer installed for the crude desalination process, stream which entering the process, desalination process, and stream which coming out. And this information is very helpful in order to make the desalination unit working in the efficient way. Recovery rate or distillation, also very important parameters. It's not easy to measure these parameters by a standard method due to method restrictions. For example, ASTM method, like D86, restricted to 350 degrees Celsius. It's something like 617.8, if I'm not mistaken, degrees Fahrenheit. Additional method, it seems dist, that can go to higher temperature, but also restricted to be effectively working with medium and heavily crude oils. This parameter important for crude distillation unit efficiency and allows having better control for distillation process, especially during the crude switch. And the last parameter, emulsion stability, that helpful in understanding better the process of agglomeration of water or asphaltens. As I already mentioned, all these parameters except metals can be measured online, and there are online process analyzers that being used in analyzing the quality of the crude oil for these parameters. Dr. Sorry, somehow I cannot move to the next slide. Can you please? Okay. Crude oil inline blending station, it's a specialized type of the inline blending station used in the oil and gas industry to blend different grades or types of crude oil to meet specific product specification. The purpose of the station is to achieve a uniform product quality for blending different types of crude oils in precise and controlled manner. Blending process involves mixing different crude oil streams with different properties such as API gravity, sulfur content, viscosity, water content, and also other parameters in order to create a final product that meets specific customer requirements. Inline blending station can be used to blend different grades of crude oil in the continuous process without interrupting the production flow. The station typically consists of several components such as pumps and valves, control systems with instrumentation like flow meters, optimization software, analytical compartment, analyzers for quality analysis of the process, blending head or static mixer, and tank farm for raw material and blended products. Crude oil streams first measured and monitored for their properties, and then transported to the blending unit. Blending unit mixes the different crude oil streams in precise proportion to achieve the desired product quality. Then blending product transported to a storage unit or further processing unit. Crude oil inland blending station is actually a very important technological unit in the oil and gas industry, as it allows optimized use of different crude oil streams, which results cost saving, improved product quality, and increased productivity. Next slide, please.
You can move.
No, it's not working from my side.
Okay.
Thank you. Standard practice for blending optimization based on the regression models. There are also more advanced methods that using non-linear modeling and neural network. Utilization of such methods enables dealing with noisy data or large-scale data that requires complex models for blending optimization and prediction purposes. The first action item to create neural network-based models is to create a network architecture and to use an input data for model training. Then, once database network architecture was established, deep learning methods can be used for the network training. Depending on the network parameters, output converted into predictions and can be provided as an output table, which may be used to generate optimum set points. And later on, this optimum set points may be downloaded to the Blender controller to establish the optimum components ratio. It's important to mention here that high quality input data availability is an important factor reaching quality control. So after we understood why there is a need in process analysis control, let's have a close look on the concepts related. One slide back, please.
Right.
On the concept related to choosing the correct analyzers.
Just a minute. Okay, you're here, right?
Yes, this one, please. Basic steps to process analysis includes choosing the analytical method, sampling and sample preparation, proper location of the housing. No, the one back, please. One slide back. Communication to control system and reporting. Slide 24, please. Yes. Process analyzer sample probes and sample transport lines designed to ensure representative and rapid sampling, avoiding a possibility of contamination. Typically, complete integrated analyzer system and all related services can be provided by experienced system integrators. Next slide, please. Following critical factors shall be considered for analytical method selection and system design. Accuracy and sensitivity. In most cases, especially when we are talking about crude oil analysis, process analyzer measuring method will be different from the laboratory. It's important to understand that the accuracy of different methods is also not the same. Initial investment and maintenance cost, selectivity and cross interference. Important to understand the complete stream composition in order to prevent cross-reference of components. Single and multi-stream applications, mainly related to time measurement and of course to contamination. If there is a need to flush stream and what will be the solvent used for that. Sample handling and sample conditioning and reference method and calibration standards, how analyzer will be calibrated. It's something that requires special attention and efforts. Next slide, please. Critical success factors. At the earliest system design stage, the process stream must be defined by operating conditions and complete sample composition. Then roadmap for process analyzers implementation should be established by considering the following critical factors. First of all, defined measurement technique to be used, availability of the same method used in the laboratory or some others. We always prefer to use the same method used in the laboratory, but in many cases, especially with the crude oil, it's not applicable. Define process streams and components to be measured, proper sampling, system design and installation, complete solution, analyzer housing based on project specifications or standard requirement, analyzers validation per ASTM and other standard regulation, how validation should be performed. Is there any local customer requirement for performance validation? It's better to agree these terms before the commissioning. It has to be agreed with the end user. And of course, ongoing maintenance and support. Since process analyzers results must be correlated finally against the standard laboratory analysis method, it's essential to select the analytical method from all available techniques correctly. We have also to distinguish between ASTM-based analyzers and correlative analysis technologies. If possible, it's recommended to consider various spectroscopy correlative technologies, which are more reliable and easier to maintain than the others. Process analyzers used to be separated to two types, ASTM and correlative. Next slide, please. ASTM-based or so-called discrete online analyzers, not depending on feedstock quality and other external factors. It provides better correlation with the laboratory. However, their response time is usually longer and maintenance is expensive. These technologies usually selected if any reliable and proven technology can be used, and they correlate well with the standard laboratory ASTM method analyzers. As an example, next slide, please. Process gas chromatography, process gas chromatograph analyzer is a common type of discrete analyzer used in analytical chemistry to separate and analyze compounds that can be vaporized without decomposition. Despite its high maintenance requirements, this technology is the only available solution for many applications where multiple components shall be measured with high accuracy. This method also requires the supply of high-quality carrier gases like nitrogen, hydrogen, helium, argon, with a very high purity of about 99.95%. On the other hand, next slide, please. The second type of analyzer are correlative analyzers. Correlative online analyzers faster and they're expensive, and they're actually less expensive, and includes mainly spectrometry or spectrophotometry measuring methods like NIR, FTIR, FT-NIR, or even magnetic resonance technique. However, validation of correlative analyzers against standard laboratory methods is only possible using special ASTM procedures. Chemometrics is a chemical discipline that uses mathematical, statistical, and other methods to build a mathematical model that explain the correlation between the measured spectra and real property of interest. Chemometrics approach uses multivariate methods of analysis like PLS, partial least square regression, and was found as an effective method to be used for correlative analyzers models bidding procedure. Next slide, please. A bit on chemometrics principle and how mathematical model is built. So in order to build a mathematical model, there is a need for spectra. If we're talking about the correlative analyzers, we need a spectra, and we need a laboratory data for this spectra. Laboratory data which describes the spectra Once we have these two parameters, we're not talking about one single sample. There is in about 20, 30 different samples. Once we have this information, we have spectra and data for this spectra, we can build a calibration model. It's happening on the calibration phase. Once we have a calibration model and we upload this calibration model onto the analyzer itself, each and every new measurement, each and every new spectra, non-spectra, multiply it on this calibration model. And this is actually provides us results of the measurement. Next slide, please. It's very important to mention here that the quality of the model depends on the quality of the laboratory. If laboratory provides high quality results, also our model will be high quality. And definitely if we get not so good results from the laboratory, it's also affect on the model. Model will be of poor quality, and it's also finally affect the results of the analyzer. Next slide, please. Sample conditioning system. Sample conditioning system intended to provide a sample in the state and condition compatible with the measurement technique used by the analyzer. Process sample probes and sample transport lines designed to ensure representative and rapid sampling, avoiding possibility of contamination or dead volumes. Without representative sampling, results of the analysis won't truly indicate the process condition, and it's impossible to correct these deficiencies with data analytical modeling. Next slide, please. Analyzers and analyzer sampling system require varying degrees of protection depending on the type of analyzer, importance of the application, and environmental conditions in which it operates. If construction and maintenance requirements not suitable for the working environment, additional protection such as using analyzer houses have to be provided. Such an additional protection ensures the satisfactory performance of the instrument and makes process of maintenance much convenient. The first type of analyzer's housing is analyzer cabinet, something that you can see on this slide. It represents a small housing in which analyzer installed individually or grouped. There is a possibility to install more than one single analyzer, something that we can see here. Maintenance with this kind of protection performed outside of the cabinet with open doors. Next slide, please. Analyzer shelter is an open structure. We can see it here on this slide, and it allows air to pass through, and as you can see, may contain more than one single analyzer. Maintenance of the analyzers is normally performed outdoor in the protection of the shelter, and you can see that the main protection that the shelter provides is protection from the sun and maybe from the wind. Next slide, please. Analyzer houses is an enclosed building or part of the building containing process analyzers and associated equipment. Process streams for analysis brought into the analyzer house, and maintenance is also done by authorized personnel inside the building, inside the analyzer house. Analyzer systems installed in the analyzer house, including air conditioning, power distribution, lighting, termination junction boxes, gas and flame detectors, piping and wiring. Next slide, please. Okay. So-called smart analyzer house is actually an effective solution for integrated scope. And these solutions mainly designed based on the international standard IEC 61285. This house typically includes a sample conditioning system with sample recovery, stream selection facilities, air conditioning, power distribution, lighting, termination and junction box, It also includes gas and flame detectors inside the house. Trend over the past years is toward remote access to the analyzers and houses facilities. It means that there is no need for the physical presence or existence at the analyzer house, and all the work can be done remotely. Next slide, please. Analyzer houses actually delivered, prepared, and pre-wired with all the equipment inside, with the analyzers, sampling systems, and also other utilities installed at the factory. Complete assembly tested and shipped to the site as a single package. Most of such projects manage usually on the base of the turnkey responsibility. When same team manage the project from start to the end. In such a way, site installation work keep to the minimum. The system is typically equipped with facilities, and you can see them on the picture: air conditioning, power distribution, lighting, termination and function boxes, gases and flame detectors, relevant piping and wiring. Process sampling probes, which cannot be seen here. Also sample transport lines, sample conditioning system, which is designed to provide sample in the condition compatible with the measurement techniques used by the analyzers, which are installed inside of the shelters. And additional peripheral equipment like sample recovery systems, stream selection facilities, internet connection, and so on. Next slide, please. When a new process analyzer is initially installed or after significant maintenance has been performed, a set of tests must be performed to demonstrate that the analyzer meets the manufacturer's specification. These diagnostic tests may require that the analyzer be adjusted to provide predetermined output levels for certain certified reference materials, so-called etalon materials, or compared with other reliable analyzers, such as analyzers which are present in the laboratory. The methods of validation and calibration rely on effective coordination between analyzer maintenance team and laboratory. So it must be an effective communication and mutual agreement between the process analyzer department and the plan laboratory. And it's always better to do it during the commissioning or even before. Next slide, please. Validation of process analyzers. ASTM developed standard procedures to validate the process analyzers. Standard practice for validation of process analyzer stream. It's actually based on the ASTM D3764, and it describes procedures and recommendations for validating a total process analyzer system. Validation achieved by statistical assessment for online analyzer system as a function of results generated by the ASTM or other established primary test methods. We should always distinguish between product passportization and other analysis. For analyzed used for the passportization or so-called certification, analyzer system precision determined by the statistical assessment and typically compared to the site precision values. For other analyzer applications, analyzer system precision determined by the statistical assessment compared to the preliminary specified performance criteria. Next slide, please. After analyzer system installation, following on-site and off-site services should be provided by system integrators. Equipment assembly and supervision, pre-commissioning and commissioning procedures, connection, wiring and system integrations, startup, setup, software configuration, calibration, validation according to the STM standard, and the site acceptance test of the complete analyzer systems. Training of customers, operators, and maintenance personnel, theoretical and practical training. Fulfillment of any warranty obligations and performing any required repairs. Long-term maintenance and remote technical support and consulting. Effectiveness of the contribution of online analyzers measured by the ability to perform their functional requirements upon project demand. Once the functional requirements identified, the supporting action items should be established. What are these? First of all, maximizing performance and benefit of installed analyzers. Achieving operator confidence in the use of the installed online analyzers, ensuring that the analyzer output data is reliable enough to be used by the operators, control systems, and other users to improve plant operation, and of course measuring KPIs, key performance indicators for the performance, and ROI for the analyzer system. Next slide, please. I would like to initiate a short discussion on targets we will be interested to achieve and modern tools used for this blending process optimization. As a common base, economically optimal process working point may be non-intuitive from the process operator's perspective, as it requires considering multiple parameters and constraints on their values. The operator's usual strategy is to keep the process parameters at a safe distance from the operational limits. The problem is that this operating point may not be the most economically effective one. The economically effective point may be non-obvious, but more importantly, it may lie close to the operational limits of the process. Please, next slide. Economic optimization may require shifting the present operating point to one closer to the limit of the controlled parameter of the process, such as qualitative or quantitative parameter of its output. However, this requires reducing the variability of the controlled parameters. In other words, economic optimization of the process requires two tasks. The first is calculating the most economical effective value of manipulated and controlled variables of the process. And the second, reducing the variability of the controlled variables to prevent exceeding the operational constraints of the process. Next slide, please. Group of advanced process control solutions responsible for bringing the process from its current state to the desired one, called model predictive control. These solutions are most commonly based on linearized approximation of the process dynamics. Model predictive control products have been used in the industry since mid-70s. The problem is when model predictive control allows effective transition from the current to the desired state, it provides no answer to question what is the optimal state is. The solution responsible for finding the optimal working point of the process have been called real-time optimization, RTO. RTO systems based on the first principle model of the process. The limitation of RTO is actually low computation speed and modeling precision. This approach, splitting advanced process control between MPC, model prediction control, and real-time optimization, has its limitation. The most immediate one is the maintenance overhead, as both systems are based on different principles of the user. Such as oil refinery has to keep dedicated staff for each one of the both systems. The challenge is to offer an integrated solution that iterativity pushes the process from its current stage towards the optimal one. The basis of the solution is the model of the process, also called digital twin, which implemented using the tools of machine learning. The core of the system is a predictive model, as already mentioned, the digital twin, and it takes as an input the values of manipulated variables, MVs, and disturbance variables, DVs. As an output, digital twin produces the predicted values of the controlled variables, which are called CVs. These CVs values represents the quality and the quantity properties of the process outputs. The optimization algorithm search for the set of MVs, manipulated valuables, producing the set of CVs, minimizing the cost function for the current set of the disturbance variables. Next slide, please. Despite the promise of machine learning for process control, a significant percentage of machine learning or artificial intelligence projects fails to achieve their potential. The next three factors actually for the failure can be assigned. Next slide, please. First of all, it's non-incorporating key process parameters in the model. The second factor is choosing applications where machine learning offers limited added value, and relying on partial on imprecise training data. These are actually three main factors where the projects related to the machine learning can fail. Next slide, please. In order to solve previously mentioned problems, a modern approach on refinery optimization involves tight integration with online analyzers. This is actually how, and we understand why there is an importance of using online analyzers while we are dealing or talking about the machine learning techniques. By obtaining the properties of the crude oil at the input of the CDU and properties of intermediate distillates as an output, it becomes possible to collect the full set of historical training data that allows building a high-quality predictive model of CDU operation. I'm not talking here not about the crude blending, but about the CDU. But later on, you will understand that it comes as a complete solution, which includes all the process units in the refinery. This approach also has two additional advantages. First of all, it allows mutual validation of the predictions for the online analyzer readings and the lab results, and also providing a timely warning when there is a consistent discrepancy between the three values: analyzer value, laboratory value, and prediction values. And secondly, online analyzers provide real-time data that can be used for continuous training of the model, keeping it constantly up to date. Next slide, please. While gradient descent-based optimization algorithm is an adequate approach for the single technology unit optimization, its scalability can be limited when switching from the single unit to a chain of unit optimization. For example, if we are going on gasoline production or diesel production chain. But there is a solution for that, and its limitation can be addressed to using a technology named Deep Reinforcement Learning, DRL. Intuition of DRL is actually the following. With gradient descent-based optimization, we don't store the calculated results and have to repeat the same calculation problem for the same process state over and over again. DRL can actually be compared to a smart lookup table that stores the optimization solution for the certain set of MVs and DV parameters. It allows pre-training the DRL in advance while instantly maximizing the optimization results in the real time. In addition, DRL allows a trial and error type of solution search that doesn't depend on historical data and coverage to the optimal control signal for any set process state parameters expressed by the current MV and DVS values. Next slide, please. Just to summarize, I would like to show a few screens of the blending station control system. This slide provides an example of a blending station overall scope, analytical shelter equipped with process analyzers, HVAC system, safety and communication utilities, static blender as a part of the blending station, and peripheral equipment like pumps, sample recovery units, and so on. You can also see additional tab, which can be seen on the down part of the slide. These tabs are actually provide more detailed information like analyzers data, alarms, or detailed overview of blending process. Next slide, please. Here we can see the blending process. It's a more detailed overview of the process diagram. We can see real-time flows, operation of the control valves, process analyzers that are being used in the blending process and its value, and of course, online results of the measurement. Next slide, please. Just to summarize this part, there are many technologies as well as analyzers available in the marketplace to analyze crude oils and refinery and products qualities. Careful consideration related to design, configuration, and supplied equipment is an efficient part of process success. Usage of online analyzers at the unit input and output facilitates high quality process modeling and allows advanced optimization based on the neural network computation tools. Next slide, please.
Okay. Dr. Ariel, thank you very much for a very nice presentation. Melissa, now we're going to start the question and answer. So can you open the chat box, please?
Absolutely. The chat box is open. Unfortunately, we do not have any questions. So if anyone has any questions, please feel free to place them in chat.
No, we have 6 questions.
Oh, I didn't receive them. They didn't put them to everyone. So if they may have sent them to you directly, the host.
Okay, this is coming from, okay, slide number 27. Now let's see which one. Okay, slide 20. Composition tracking of ADU feed tanks based on which technology, how to detect stratification. Slide 20, the crude composition in the tank is done by a software, and also which crude goes in the tank first. So they keep a track of the crude composition, and that software also takes care of the stratification. We are assuming that there will be enough mixing in the tank to create a uniform. But the software like SigmaFine and other software which gives the crude composition, I have worked with a few of them. Which analytical technology to have accurate measurements of resins and asphylates? Ariel, can you answer that one? Slide
Yes.
21.
Definitely. In order to measure the heavy content, there are actually a few methods. One of the methods is GC, but the preferable methods is actually correlative analysis based on the NIRF, TIRF, and other spectroscopy technology. This analysis is actually have its advantage over the standard methods like GC because it's online method, and results actually provided on the second scale regime. Also, maintenance of such an analyzers, correlative analyzers compared with the maintenance of GCs is much easier. As well, this type of analyzers does not require any flow or calibration gases, and definitely it's actually the best solution for measuring the heavy content, like residues or complete content of SARA. And it's actually the method which is recommended for this type of the measurement.
Yeah, this message, you're not able to see it because they are sent directly to me. So it should be sent everyone so everybody can see it. Now, the slide number 27, when a given quality determination can be obtained through differential or different analytical methods, what are the criteria to use? Take, for instance, DVP curve by FTNIR or NMR.
I think this question is similar to the previous question comparison between the different methods of the analysis. As I already mentioned, it actually depends what is the quality parameter that we are looking for. If we are looking, for example, for a salt quality parameter, there are no much methods for that, and the one and only method which is available for the measuring of salt, we are talking about the inorganic content of salt in the crude oil. It's actually STM method, D3220. And definitely if we're talking about the heavy content or distillation points, as already mentioned in my answer for the previous question, the preferred method is NIR or FTIR or FTNIR.
Okay, next question is slide 34. How do you protect your crude sampling system from water ingress or paraffinic deposits?
Protect from water?
Yeah.
My understanding that protection from the water for the measuring purposes. Is that correct? I mean, there is actually no need to protect the system from the water because water may be one of the parameters we would like to measure. But generally speaking, if we do have water in the stream, does it affect on other measurements? Yes, for example, I think maybe the question is if water affect the measurement of a NIR or FTIR analyzer. Right. So generally, no. Okay, it's actually depends what is the measuring range of the analyzer. Okay, because the water has a very strong signals in the I think 1,400 nanometers, maybe so on. So we just have to choose a different measurement range. And once we choose a different measuring range from the which is different from the absorbance of the water, it actually doesn't have any effect on the measurement itself.
Next question is, what do you think is the most important to measure water in crude?
Why it's important to measure water in the crude?
I think he said why. Castillo, is it a why or what?
What are the methods? Why, first of all, we don't want to have water in the final products, okay? We don't want to have water in the gasoline. We don't want to have water in the diesel. That's why we need to know if we have water and, of course, make the separation process more efficient. How we measure water, there are actually a few methods for the water measurements. The most stable, I think, the most popular method for the water measurements for the online analysis is based on the electric constant.
Yes, I don't think I have any more questions. If anybody has a question, they should set their settings to everyone so everybody can see it. Okay, Melisha, go ahead.
All right. Well, thank you all so much for your questions. I do apologize. I did go ahead and make that adjustment. So if you do have any additional questions, please go ahead and place them into chat. And please remember to select everyone. I do believe that it was only allowing you to send it to the host. So I do apologize for that. And at this time, I'll go ahead and place the poll question on the screen. Please go ahead and respond to the two questions. We do appreciate you joining us today and hope that you can join us for the others that we do have scheduled. Please look for that. Thank you so much for joining. Once you have responded to the questions, this does conclude today's webinar. Have a wonderful day, everyone.
Thank you for candid feedback. Please take a few minutes to give your feedback on the Google survey form, which you will receive in your to you.